Good morning, everyone. Myself, Kishan Shinde. My USN is 1VE20CA010. I'm pursuing my engineering in Sri Venkateshwara College of Engineering in the domain of computer science engineering with artificial intelligence. Today, my topic is Find S algorithm in Python. Find S algorithm is an basic algorithm in a machine learning. Let's see more about it. Introduction. Find-S algorithm is a basic concept learning algorithm in a machine learning. As I said, it is a basic concept of learning algorithm in machine learning. The Find-S algorithm finds most specific hypothesis that fits all positive examples. A Find-S algorithm finds most specific hypothesis. A hypothesis is known as a conclusion. You could say a conclusion, the specific conclusion that fits all the positive examples. We have to note that here the algorithm considers only those are positive training examples. Here in Find-S algorithm, it considers only the positive examples, whereas the negative examples are not considered. Those are ignored in Find-S algorithm. The Find-S algorithm starts with more specific hypothesis and generalizes this hypothesis each time it fails to classify and observe positive training data. So, Find-S algorithm starts with more specific hypothesis. It has a specific conclusion, and later it generalizes this hypothesis each time it fails to classify and observe positive training data. So, at first, it has a specific hypothesis given. So later, whenever the data is being given to that, it generalizes the hypothesis whenever it fails to identify the specific hypothesis in the data. Hence, find-S algorithm moves from most specific hypothesis to most general hypothesis. So hence this is in find-S algorithm, the first there would be a specific hypothesis from which a general it moves to a general hypothesis due to the failing of the classification of observed positive training data. Important representations. The question mark indicates that any value is accepted for an attribute. So question mark is a general hypothesis where it indicates that any value is being accepted as an attribute. Specific Specify a single required value for an attribute. A single required value is being specified. Phi or the zero and a dash within it indicates no value is being acceptable. So this symbol means that it has a specific hypothesis. So this phi means that no value is being acceptable. The most general hypothesis is represented by question mark, question mark, question mark, question mark. So just as said, question mark is any value being acceptable becomes a general hypothesis, and the phi becomes a more specific hypothesis as it does not accept any other value. It accepts only the value it's been given. So let's see more about it. Steps involved in find-S algorithm starts with most specific hypothesis that has 5. So specific it has a specific hypothesis. Take the next example. If it is a negative, then no changes occurs in the hypothesis. So at first the hypothesis would be 5 and it would be given there. So the next example which or the next data which it takes, if it is a negative, then no changes would be occurred. The hypothesis remains the same. If an example is a positive, then it takes the data within it, and we find an our initial hypothesis to too specific, and we update our current hypothesis to general condition. What happens is that whenever a positive data is being taken, if the hypothesis is too specific and we need to update the data, then it turns into a general conditions where the specific data or specific hypothesis, the data which is being given is specific and the general conditions is both being acceptable and turns into a general condition. Keep repeating this above steps till the training examples are completed. This converting into a general conditions is kept on repeating until the data is finished. After we have completed all the training examples, we will have a final hypothesis when we can use to classify new examples. After all these training data being verified, a final hypothesis will be obtained, which can be used to classify all the examples. Let's see an example. This is an example where uh, four columns is being given: color, toughness, fungus, appearance, poisonous. So here the target data or the data which is positive or negative is given by poisonous. Yes or no. We take into account only the yes or the positive this thing, positive data. Negative data, whichever the no data, that is second and third row, is being neglected. First, fourth, and fifth, sixth, seventh has been taken into account. Let's see. First, we consider the hypothesis to be more specific. We our occur would be 555. Consider the first example. Our the data in first example is green, hard, no, winged. We see that our initial hypothesis is more specific and we generalizes for this example. Hence, the hypothesis becomes green, hard, no, wing. So the first would be 5. Next, after becoming generalized, it becomes green, hard, no, winged. Next example, we see that example is negative. So we neglect that data and we keep the hypothesis the same. That is green, hard, no, winged. The third example we see is also a negative. We neglect that data and keep the hypothesis the same. The fourth example is a data where orange, hard, no, winged is being given. The mismatch is found to replace a particular attribute in a general case. That is a question mark. We are doing this process after it becomes the first becomes a question mark, hard, no, winged. Question mark, hard, no, winged. Because the hypothesis was green, hard. Here, orange has been replaced. So we have to generalize that data. So question mark is been replaced in that direction, in that place. The data present in the fifth example is green, soft, yes, smooth. We have to compare every single attribute with the initial data and mismatch the replace found in the attribute with general case, that is question mark. After doing this process, the hypothesis becomes all the question mark. Since we have reached the point where all the attributes have become a general case, so the final attribute becomes the same. Hence, the final hypothesis would be question mark, question mark, question mark. Algorithm for an general finders algorithm. Initially, H is to be specified, that is hypothesis in hypothesis H. For each positive training instance X, for each attribute constraint A in H, if the constraint A is satisfied by X, then do nothing, else replace A by H by the next more general constraint by satisfying by X. This means the same I told. Whenever we encounter positive data, if the positive data is same as the specific hypothesis being mentioned, we do nothing. If it is changed, we replace it by a question mark or an A here uh, to make it a generalized constraint. Output of the hypothesis would be obtained in each. So let's see a program or a code for a finders algorithm. First, we import CSV. That is a module which imports the data from an anything. So we mention an array A with an command as we with open enjoy sport.csv or as a CSV file. We open the enjoy sport CSV file with a read option and for road as read option with a row in csv.reader and a dot append. We append the rows and print those. So next print len a. So whatever the length of an a 0 is being printed, the num attribute variable called num attribute is being taken with length is being decreased. That is the positive and negative of an data is being neglected. It's just used to verify that. So we minus that there and we take it as num attribute. So print number of attributes as num attributes. After neglecting that attributes, we print those. So print type initial hypothesis. The initial hypothesis would be the first hypothesis which is being given. So and we print that hypothesis. Next, for I in range 0 to length A. If A if A dot A of I is equal to num attribute is equals to S. For J in range 0 to num attribute, if hypothesis j is equals to 0 or hypothesis of j is equals to a of I comma j and hypothesis of j is equals to a of I Else, the hypothesis A of j is equals to question mark. Print the hypothesis training instance uh, as dot format I plus one hypothesis. What here this code means that, so whenever you start verifying it through a for loop. So first, whenever you encounter yes condition, you go inside that. So next for loop is being checked whether the attribute we are verifying is same as the specified attribute that is being mentioned at the starting of the program. If those both are same, we keep it the same. If those both are changed, we change it to question mark given here and print the hypothesis in the statement. So print the maximize specific hypothesis in the training instance and print that hypothesis. So this is it. Thank you. I hope you would have understand.